is like the, day zero metal organic framework
Right.
that sort of led to all of the developments and then created the Nobel Prize today. So we know that these things are possible,
Right.
right?
Because
But
they occur in nature.
yeah, they occur in nature. The idea is we want to be able to engineer
Hmm.
and very specifically put stuff together, okay?
In order to basically get the emergent properties
Yeah.
that we're looking for.
Yeah, yeah. And in order to figure out exactly how we're going to do this engineering, we need to do a little bit of basic chemistry. Always, you got to start from first principles.
Mhm,
So we go to 1913. Alfred Werner wins the Nobel Prize in 1913. He basically starts this field of coordination chemistry. Okay, he starts thinking about metal ions and how metals can bond covalently with other atoms. And he characterizes these tetrahedral complexes. Tetrahedral meaning the like four,
Yes.
tetra meaning four.
Yeah.
So four bonds that are in this like sort of nice crystalline pyramidal structure.
Mhm.
And these bonds between the metal atom and the other atom is what's called a coordinate bond, okay? And this is different from a covalent bond. So if you go to the next slide, I'll show you what the difference is. So in a normal covalent bond, you've got shared electrons, right?
Yes.
In O2, for example, oxygen and oxygen, each oxygen is sort of donating an electron to the bond to create the O2 molecule. Same thing with CO2, H2O. With a coordinate covalent bond, there's only one donor. Okay, the other
Okay.
guy's kind of leaching.
Okay.
Okay, so over here you've got, on the left-hand side, you've got the yellow atom that's got a full shell with 8 electrons,
Yes.
and then on the pink atom has two holes.
Right. That is.
So the yellow atom goes in and donates. Now everyone has full electron shells and everyone's happy. This is called a coordinate covalent bond. Okay, and this is going to be the sort of building block of the chemistry that we're about to talk about, that won the Nobel Prize, okay?
Got it.
Because metals make ions, right? And what ions, usually with metals, the outer electrons, which are in the D shells,
Yes.
that are like far away from the nucleus, they're just gonna go away.
Right.
So you're gonna get like a copper ion, which is Cu plus, that means 1 electron left, or the ones we were talking about, iron 2, iron 3, that means 2 or 3 electrons left. So they got these holes. But now other atoms can come in and fill that gap, and you get a coordinate covalent bond, right? And that's going to be the building block for the chemistry that we're about to talk about. That sort of led to all of the developments and then created the Nobel Prize today.